my really pleasure to be here today. You know, MXD is, in Siemens, we know MXD from the very beginning. We have been members from the very beginning. We know them for many years, and we had many projects. That's why it's an honor for me to be here today and to give you back the vision we have in Siemens about industrial metaverse. And also to thank you also for the great partnership we have, all the good projects we are doing here. And I'm sure my colleagues in Siemens here can confirm that. So, as you said, I'm representing the corporate research of Siemens. I have a global role. I have people with me in Princeton, New Jersey. It's our Siemens hub of research in the US. But we have also other digital twin experts in Germany, in China, and India. And it's my pleasure today to share with you the vision of Siemens in industrial metaverse. You see in the title, we talk about the hype. Because what is confusing is to battle against what people think about the metaverse. It's always confusing. It's always a little bit the downside, saying, oh, yes, it's just a hype. Actually, for the manufacturing and for the industry in general, it's very, very important vision, and this is our future. That's why it's super important to share a common understanding. Well, I start with a little picture. It's not a family picture, it's a team picture. It's a selfie of my team in 2021, and it's a team of avatars. And you see they look a little bit weird, to be honest. Because it's an avatar how they look like in this particular platform. That at that time was spatial, but we tried other platform. And we had a team meeting, and it was the first time. We were all equipped with Oculus system, and we were connected to the spatial platform, and we had a cool place. It was like a virtual meeting room. We even had a cat, just to share with you. Anyway, and it was the first time ever we connected in this platform. And I can tell you, I'm a sort of geek. I was very impressed, and it was very emotional. Because the second thing you must know is that during COVID time, we were all connected from home. We were in lockdown at that time. And it was the first time we were together. Together means we can shake hands. We could talk together one by one as a group. We had a lot of fun. It was very emotional. And what you don't know also in this picture is that the lady in the middle, called Mareke in the blue shirt, she was connected from San Francisco. And the boys in the front, they were in Munich. And I was in Princeton with Thomas and Lucia. So just to show you that we can be in the same place together virtually, even if we are all around the world. And that's why it was the real emotion come from that, with a top layer and cherry on the cake with COVID, that it was emotional to say, look, we can work together virtually. Well, why I'm showing that, except I share my life, it's just to tell you that it's not the industrial metaverse. It's a technology that is, by the way, super interesting to experience. But this one, we call it the enterprise metaverse. It's a virtual workspace where we can have interactions. It's the future probably of our Teams meeting, or the Zoom meeting is probably the future. It's super cool, but let's see when it's coming in real life. But it's not for the industry. The second type of metaverse is we call it consumer metaverse, is for the gaming. It comes from the gaming. You can buy stuff virtually. You can have entertainment. You can play with players, social media interactions. This is the second type of metaverse. And the third type I'm going to talk about today is the industrial metaverse. And this one is using more or less the same technologies, but the point and the purpose is very different because it's really about designing and operating real-world system, because we are doing serious things in factories. That's why we need, it's not entertainment, it's not a social interaction, it's really about providing a tool for manufacturing and industry in general to operate with these new technologies. So before going into the metaverse, what is it exactly for industry, let's talk about the digital twin. Because, you know, the metaverse in the end is an evolution of what we are doing for many years. And the digital twin is really the core component of metaverse. The digital twin is a virtual representation of something that is real, and is the digital version of a real world. And both together, digital and real, together represent the comprehensive digital twin, we call in Siemens. The comprehensive digital twin contains all the information, all the data, all the model we know about this system. And thanks to the digital twin, we can predict and optimize. This is the definition of a digital twin, and there are plenty of already good examples. And I forgot to tell you that it's all along the life cycle. You can start very early at the design phase, and by the way, when we are in design phase, we don't have the real part because it doesn't exist yet. That's why we call it sometimes digital prototype or digital mock-up also. And there are cool examples of digital twin at this early stage of the PLM. For example, we worked with a Danish research lab called DTU, and thanks to digitalization of what they are doing, and they are working on blades for wind turbine, they could reduce the cost of the test by 30%. They could also implement the test 5 times faster thanks to digital twin. Just to give you an idea of the power of the value of using digital twin in this early stage of design and even testing. The second usage of digital twin is about manufacturing, and the digital native factories, the beautiful, I would say, lighthouse or example of what we can do in digital world. Digital native factories, they are built, they are designed, built, and operated in virtual life before being implemented in real life. And they have proven to be very, very efficient and very productive and sustainable. It's a beautiful example. I talk about greenfield because, of course, it's where we can have the more access to the data, the original data, but it works also for brownfield factories. And I'm going to show you later an example, because once we have the data, we can play around and do more prediction and optimization. So what is the industrial metaverse in this story? It's actually, it's a space, it's a place where we can meet the digital twin. We can interact with the digital twin. We have the component immersion of being in a virtual place, and we can touch or we can see and we can turn around the digital twin. We have the interaction piece of the technology where we can modify something, or maybe we can talk to some people. This is the collaboration piece. And we can also, with the data, play around, including monetize it as a marketplace. That's why, as a summary of what is a digital twin, and the metaverse in this particular case, it's really, and you see here a movie that is a metaverse. That's beautiful. It's very photorealistic. And thanks to this immersivity, you have a tool for you to be in the factory without being really in a factory. And maybe the factory doesn't exist yet. It's a very impressive tool for you to communicate, to work remotely, for example. Now, this is the first component. The second component is the concept of being real-time. You know, the metaverse is a persistent place that exists even when you log out from your computer. It still exists. Somebody else can come. It's like a factory, virtual factory, and you come. And you have this real-time interaction. You can leave some comments. You can interact with other people. And you have this persistence, but also this real-time component. In this metaverse place, you have also the physics. because, you know, the confusion and the hype has a role to play in this story. When people say it's a cool place, it's just beautiful, that's true, it's beautiful, because it's coming from the gaming, the technology of photorealistic, very impressive rendering. We could say, okay, but it's just a movie. In the case of industrial metaverse, and in particular in Siemens, we are very attached to say that we have a very high fidelity representation of the physics, and we have a lot of software in Siemens to predict flows and structure and many other components of the life in the factories. That's why in the industrial metaverse, you have the real physics. You predict really what's going on and what could happen, and you have the data of what happened. That's why it's also a travel. Some people call it traveling in time. You can go back in time to look at the data and see what happened, and you can predict the future with a simulation, high fidelity simulation, and that's a tool for you to also work on that. And the last part is the monitoring, because of course you have a nice place, you can interact, you can visit, you can work with people, and it's a tool for you to monitor and analyze what's going on in this place. And in this case, you have a virtual factory here. We'll show you a movie later. It's not a revolution, it's an evolution. Nothing happened. Believe me, I've been working for 30 years. I've been in research for more than 20 years. Nothing happened overnight, to be clear. It's part of the hype also. You know, last year was a hype of metaverse. This year it's a hype of AI. Well, AI exists for 50 years. Metaverse is a new name of the simulation that exists for 50 years also. And the next 50 years, they will exist too. Just to be clear, to relax everybody. But we have to be also understanding that the evolution is slow, but it's sure. That's why it's coming. You see at the very beginning, by the way, I was a simulation engineer 30 years ago, and I was doing a simulation of car bodies. And I have seen in the industry, because I come from the automotive industry, a lot of evolution of the CAD system, of the simulation, the possibility to predict physics. And it has become, with the system engineering, a very important tool in the industry to build a new product and to manufacture products. And that's why we went slowly to digital twin era. We know today, and the future. We have defined the industrial metaverse, because in the meantime, it's also a technical evolution. Another picture we have to explain the evolution is, again, nothing happened overnight. You have been an evolution of hardware and of the software that bring us to today in this virtual crossing the reality, the real products, hardware, software meeting point. And the future is industry metaverse, because we have also these immersive tools. Today, the goggles are very cheap. In the past, it was a very, very expensive product. We needed a full computer to run it. We needed the glasses, ugly glasses, very expensive. Today, it's becoming very common, very cheap, and very performant. That's why it's coming also with the evolution of what I call enablers. The computing power so is very, very an important component. In the past, it was very time-consuming to compute such visualization, beautiful visualization, and simulation in real time. It was just not possible. Now we have this immersivity in real time that is just fantastic, and that's why everything is coming together. The connectivity is also an important component, to be able to be connected to the cloud, or to have information on the edge and to run very fast simulation. You see on the picture, the XDT means executable digital twin. It's the family of digital twin. It's a child. It's a condensated. It's a small version of executable of a digital twin. We can execute on-premise, in the edge or in the cloud, to bring information and additional information to the control loops. So this is a full evolution, and again, we are glad to be part of. And the metaverse is also a set of technologies. Of course, the digital twin is a core component. It's a building block, the core building block of the metaverse. But you have plenty of technologies around to enable and to make it happen. Of course, we need connectivity. We need a good computing power. We need AI, because in this place, even virtual, we are going to ask AI to help us. We are going to be a chatbot to answer some questions and to have an avatar friend, a colleague, to help us resolve some problem. That's why it's a set of technologies that are needed. Of course, cybersecurity, as you said, Bernardino, it's very, very important also to ensure the security, the trust we can have in this place. It's the same like the web, you know. When you go to internet, you have the same interaction with something that is gigantic and fantastic, but also you want to be sure of what's going on. It will be the same in the metaverse. So what to do with this stuff? Basically, once we have this beautiful technology, it's in the future, and say, okay, and so what? What does it mean for my company, for my industry, for my manufacturing? First of all, we see a very different type of applications, very concrete. We are already using in some cases. At the very beginning of the life cycle, you have the design and engineering phase, where you can be immersed with the CAD, with the digital representation of your future product. And maybe you heard about Siemens is partnering with Sony to have the immersive engineering. Sony developed new glass and new devices to give the designers in the office an immersive component that helps them to interact in the 3D model. Today, they look at the 2D screen, and that's fine, and they have a beautiful rendering and beautiful information to help them design the best product, but in the future, they will interact in 3D, in virtual life. And by the way, the designer of the stylist, they are already using intensively in the automotive industry. They're already designing and seeing in real manner, photorealistically, what they are doing. That's why it will be also a place where the engineers can collaborate. I explained to you that they can meet around the digital twin and they can design together with different, maybe multi-competencies to come together and design a new product. Thanks to the photorealistic rendering, we can use it to validate. In particular, for autonomous driving cars, you cannot run millions of miles to be sure that the system is sure. That's why today these systems are trained with virtual environment that are very photorealistic. You can create some scenes that are unusual, to validate the system. That's why the metaverse will be also a place where you can, thanks to the synthetic data, train your system, the system who needs a visual rendering for actions. In the production life, of course, you have seen some beautiful pictures and movies about that. This is a tool to do virtual commissioning. It's nothing new, virtual commissioning, we know that. But in this case, it gives an additional information about seeing a new machine, for example, in your shop floor. When I say seeing, it includes all the data. That's why you can also have all the data of the software, of the hardware of this device, and you can put it virtually in your factory. It could be a full digital factory, or it could be also with a tablet, an augmented reality. You can visualize a new machine in your shop floor, and you can also connect, check, verify that the software is consistent with all the rest. In terms of operations, once everything is fine, everything is running, you have an augmented tool for you to operate the factory. Because you have seen that if we can connect all together virtually, you can ask maybe an expert that is around the world, far away, to help you solve a problem. Because the expert can maybe visualize virtually what's going on in the digital part of the factory, and to do a remote assistance. And finally, already presented by Bernardino, it's about training people. The shortage of experts is coming, and we need absolutely to train our people, new workforce, easily and fast with the new technologies, and there are already a lot of tools available to train virtually. And what is cool also in this case is that you can create some cases that don't exist often, hopefully. You know, dramatic cases where we can train the people to react, and otherwise in real life they will maybe don't see it so often. So, and what we do, why we do all this stuff, except it is cool, is that it gives us a tool to innovate faster, to innovate safe, high-quality product, to run performant places of production, and also to train our workforce. And all of this stuff is also to save money, to be more sustainable. I think you understand what I mean when you have a new tool. It's really the ultimate goal is that it's not to experience fancy new product. It's really to have this for your operations, and this is why we like to work on these topics. Well, now I'm going to talk about a real example of factories. It's our Siemens factory in Erlangen, because it's our customer zero or blueprint for industrial metaverse. In Siemens, we call it, we drink our own champagne. So I don't know where I come from this French reference, but this is how they say. That's why we are not only providing software and hardware to be sold to customers, because we use them also for our own manufacturing site. And Erlangen in Germany is a beautiful factory that has just been awarded last year as a digital lighthouse factory by the World Economic Forum. It's a very prestigious award that recognizes the digital implementation and the performance of the manufacturing in this place. And it's a pride, of course. For us as a researcher, it's also very emotional and we are very proud because they are the ones who are using industrial metaverse to do the operations. And that's why I'm happy to show this example. It's a pretty old factory. It's a brownfield in this case. It's a 50 years old brownfield. But they have an extension. That's why they have also a greenfield portion of the factory, part of the extension with a lot of digital information. And they have a journey and they have a goal, ultimate, how to be more efficient, more sustainable, to have a good, high quality. And they are doing a super job. And they are running in this place specifically more than 100 use cases of digital applications, both AI and digital twin, for a couple of years now. And they have achieved tremendous transformation. That's why the World Economic Forum recognizes this performance. For example, I forgot to tell you, it's an electronic factory. They are producing a semiconductor for motion control products. And in this factory, they have, for example, implemented a new place to clean room place where they can produce this semiconductor in 11 months. They created and developed and implemented in 11 months thanks to the digital version of this new portion of the factory. They have also energy management, very smart energy management. They have been able in 2 years to reduce by 50% the energy consumption and the carbon footprint. Quick example, honestly, I don't have the full list, but just to show you the quantity of performance you can target with hyper digitalization, both AI and digital twin. And in this case, they are using also industrial metaverse applications. We have developed with them a total virtual cell in the factory where they experience how an expert can connect virtually, remotely, and helps a worker to solve a problem. This is a very interesting case. And they have also augmented reality technology to help the workers execute the technology. Well, another example that is cool also is a project we have done with a startup. It's called Fryer. 2 years ago, it was presented at Hanover Fair. It's the first industrial metaverse representation of what is possible in a full factory. Well, this is a long version, so I go to the short version of the factory here, factory tour. So you see a total virtual factory. This factory doesn't exist. It's pure greenfield. And we have implemented in this factory that is designed for battery manufacturing, all the technologies that they need. Here you have a mixer of components. You have a robot. We have places, different components of the metaverse where they have all the data. You see all the data related to this system. Here's the energy management. And later you will see the shop floor. You have the full version on YouTube, 6 minutes. So today I decided to show you a short version. Here you have the avatars in the production line. Okay. I encourage you to have a look on YouTube on the full version. What you have seen here is nice. It's like a movie. It's super photorealistic. It's full of physics. For example, the mixer you have seen come from a real simulation of how to mix products together. And it's come from a simulation with 30cm+. And it's a real result of the physics. That's why it's a tool for engineers who want to connect and to visit virtually the factory. They have the information. Same for the robot. The real information about how it is operated, what's going on. And on the factory shop floor, you have seen the 2 avatars. They come from Process Simulate, and they come from also Technomatics. Jack and Jill, is the name of the avatars. They are real avatars with real ergonomic information inside. That's why it's beyond the movie. It's really a tool to build a factory that will be efficient, that will be ergonomics for the workers. And it's a nice example. And it was very popular 2 years ago in Hanover Fair, and we are working on other examples. And cherry on the cake, now we have all this data. They are simulated. They can be measured and implemented in the metaverse. You have a massive amount of data and information. You can chat with AI to find information, maybe to predict also, and to have a sort of summary. Well, this is a vision, so for the moment it doesn't exist such a format, but just to show you that the future, on the second hype we are dealing with, is also to have AI with us, a sort of co-pilot in this virtual factory. Okay, well, I think I'm on time. And thank you for your attention. I hope you liked it.
Thank you, Virginie. We're not going to let you leave just yet. We do have a few minutes for questions.
It's my understanding that Siemens is offering this, the collection of technology as a product for companies, but then I did hear you say that you work with companies to develop this within their factories. What is that kind of relationship then? Are you also paying for consulting to ensure that you can get this integrated into your factory appropriately?
So personally, I represent the research department. So we are doing this technology development and vision for our business unit and our colleagues. And if you want to talk to Siemens colleagues who can help a customer, you to implement such innovation, they are the one you are going to interact. So the answer is yes. I can, maybe later today you have some visit in the factory, mini factory. You can have such a question. I'm happy to help you connect. But yes, we help. Because to be honest, this is beautiful, but it's also complex to have all the data, all the models, to understand what we want to do. Some questions we have sometimes is what is the value to do that? It's a fair question. I think the main way to do it is to have a quick understanding, a use case, and to test it and to have a quick understanding of the value, and then to scale up. That's my recommendation, because I anticipate the next question, how to do that. So yes, happy to help you implement.
Are there digital tours, other factories that we can go tour that don't require a password, that I can take this back to my colleagues, showcase this to other manufacturers and say, go check this out, go experience this, so that they can get excited about it too?
Mm-hmm. Yeah, you're right. It's one of the benefits of this virtual tour is also to go virtually physically in a place where you can showcase the vigilance has to really be sure to be explicit that it's a real factory in the real life, or future factory in real life, and it's a real physics beyond. It's not just a movie and a cool place to. That's why it's really the vigilance I want to have, because of the misunderstanding sometimes, saying, oh yeah, but it's just. Yes, it could be a tour. If you have your factory in digital version, you can tour it with your customers.
Thank you, Virginie. Excellent presentation. I have two questions. One is that how much time and effort does it take to create an industrial metaverse like the one for Freyr? And a related question is that how can a business justify the investment, kind of the ROI associated with building an industrial metaverse?
No, it's an excellent question. This one is a first factory we have done. It's a little bit special. That's why it's, of course, an investment in terms of time and complexity. My team was involved, but not only our colleagues from the Digital Industry Software. We did it in a few weeks, actually. It was for another fair. We wanted to be ready. My team worked over the clock, because I have team in India, in US. So overnight they were exchanging the models and so on. It was a nice story. We don't do this every day, but because we wanted to show it's possible to do that. Now it depends on the complexity, and here you have the full factory because we wanted to show. But you can start with just a cell. Just a robot and a small conveyor and maybe 2 or 3 other components. It's as far as you have all the information, you can quickly implement. I don't know how much time, but maybe a week. I don't know.
Hey, I'm Paul Davies from Boeing. I'm just curious to get your thoughts on the rate of evolution of the industrial metaverse, maybe specifically AR and VR, and how it relates to other technologies. Because for 15, 20 years, people have been asking me and others, when are we going to see everyone running around with headsets on? And it always seems to be a few years away. So I'm just curious if you have general thoughts on that topic.
I share your pain about that. Because as I said, it's evolving very slow. And but because it's the nature of innovations and technologies. And the problem is it's a difference between the expectation and the reality. We see a tremendous acceleration with AI, with time computing performance, and so on. That's why we see some immediate acceleration, but the maturity of the technology takes time. The acceptance also to train everybody to use it and to understand what they can do. That's why I know it takes time, and I know you know, a couple of years. And that's why we as researchers, we are aware of that. Sometimes in companies, we are not well understood about the time scale is different, but we have to be consistent. What my recommendation is that to be consistent and to keep the vision and to keep the history also, because sometimes it gives you an understanding of what could happen. in the future. It evolves like it should be. I don't know what you tell me. I can tell you more.
Thank you, Virginie.